Well, so a good subgrade, again, the subgrade is the foundation under the roadway. Just like we want to have a good foundation under a house or under a building. We want a good solid foundation, and it needs to be basically strong and stiff. So a good base material there, we want to have something that's more drainable. So again, the base material is on top of the foundation, on top of the soils, and directly under the pavement surfacing. So there we want to have it drain well, because we got, especially in Minnesota, we've got lots of rain and snow, and then the springtime we need to have that base material drain very well, so that when the trucks are driving in the springtime, things behave well, and the pavement surface performs well over a long period. So the dynamic cone penetrometer, the shorthand letters are DCP. That's a cone penetration test. So we drop a weight and drive a cone pointed rod into the ground, and that's a measure of strength. And so we use that test during our quality assurance procedures to make sure that whether it's the subgrade, the deeper foundation, or the air good bases under the pavement, they're of an adequate strength. And so then another device that we use for quality assurance of the pavement foundation materials is the lightweight deflectometer, or LWD. Rather than driving a cone into the ground, it's a plate load test. So there's a steel plate that rests on the surface of the air good base, and then we drop a weight on top of the plate, and then we measure the movement of the plate. And this test, this lightweight deflectometer, is more like a traffic load, or like a truck wheel, because when we have traffic on the pavement, each time that a truck goes over it, it moves a little bit, it deflects a little bit, and we want it to come back like a spring. And that's what this lightweight deflectometer, it kind of simulates that kind of a loading. You get this spring action, and so we essentially measure the movement of the spring or of the air good base. So this falling weight deflectometer, similar to the lightweight, but again, actually the FWD, the falling weight deflectometer, came first. So that's a larger, it's like a boat trailer size device, and that's heavier loads, again trying to simulate a truck. And so the falling weight deflectometer again simulates truck loads, and then we use the lightweight deflectometer on construction sites typically. Also, another test that's more sort of a traditional test is a nuclear density gauge, which besides density also measures the moisture content. And so that's a device that's been used for many decades. It again measures the density of the air good bases in the soils and their moisture content, but that's an adequate, has been used, it's a traditional test, but due to our new design procedures, it's much more effective and efficient and useful to measure the actual stiffness or the strength. That's why we use the dynamic cone penetrometer or the lightweight deflectometer, because it correlates directly with the way that we design pavements.
So this is a gas permeameter, and even though we're using just air in this case, the idea is that we're measuring the drainability of these aggregate base materials. So typically, again, we're not worried about air, we're worried about water, and we want the aggregate bases that are under the pavements to drain well. And so then this device just measures the openness or the ability of water to move easily through that aggregate base.
Well, the pavement foundations, whether they're the aggregate bases or the deeper subgrade materials, we are currently implementing a new methodology as far as pavement design, and so we're using these test sections to essentially to validate those design processes. So over the long range plan is to both use the measurements that were here at MnROAD to calibrate the design process. And then going forward, we'll be doing more implementation on the actual Minnesota trunk highway system, and again, linking that back to the testing that we're doing here.